In this video, we're going to study hyperbolas. Now recall that an ellipse is a set of all points where the sum of the distances from any of those points to two fixed points is constant. Now, in a hyperbola, we're just going to replace the word sum with difference. So we're looking for all points where if you take the difference between the distances from the point to these two fixed points, then that difference is constant. And remember that you call these two fixed points the foci, just like we do in an ellipse. All right, now with hyperbolas, there's always two parts called branches, and if we take the line segment that joins the vertices of the hyperbola, where those branches are crossing our axis, we call that the transverse axis. All right, so here's what a hyperbola might look like, and here's one where the transverse axis is the x-axis. Now the first thing to notice is that when the transverse axis is the x-axis, the x is in the positive term and the y is in the negative term. So you see the similarity between an ellipse equation and a hyperbola equation. They look pretty much the same, it's just that instead of a plus sign between these terms, we have a minus sign. So we're going to still call the vertices negative a comma 0 and a comma 0. And the foci, we're going to still use negative c's comma 0 and c comma 0. But this time, the way that the a and the b relate to c is that c squared equals a squared plus b squared. Okay. And the other thing you'll notice is that there's asymptotes involved with hyperbolas. And the asymptotes are y equals b over a times x and y equals negative b over a times x. All right, so with these asymptotes, you also see this box here, and this box is just there to kind of help you construct the hyperbola. So it has a width of 2a and a height of 2b, and the asymptotes just go through the corners. So another way of thinking of how to draw your asymptotes is just to draw this box from negative a to a and from negative b to b, and then just know that your asymptotes go through the corners of that box. And then if we have the transverse axis as the y-axis, then you just simply get the same sort of thing, but the y term is positive this time and the x term is negative, and your vertices are of course on the y-axis instead. Then the asymptotes are a over b times x and negative a over b times x, for obvious reasons, because this is the slope of a line and it's the change in y divided by the change in x, which would be a over b or negative a over b. All right, so when sketching hyperbolas, the general principles we want to abide by are: first, go ahead and sketch the construction rectangle, right? And the construction rectangle is always going to have a length of 2a and a height of 2b, right? 2a, 2b, or if it's this type, then 2a might be the height and 2b might be the width. Then we're going to sketch the asymptotes, right? So however the box turns out, the asymptotes are going to go through the corners of the box, and you'll excuse my very poor rectangular boxes here. Then we can plot the vertices. Right, put the vertices at the edges of the box. And then from there you can sketch the hyperbola by starting at the vertices and then just allowing that hyperbola to approach the asymptotes. All right, so there's a very sloppy version of a hyperbola there. All right, so let's do a little better job in this one. It says find the foci, vertices, and asymptotes of the equation 9x squared minus 4y squared equals 36. All right, now just like with an ellipse, we know that what we always want is to have a 1 over here. Right, so I can start by saying to get a 1 over here, I need to divide everything by 36. So let's do that first. But when we do that, we get x squared over 4 minus y squared over 9 is equal to 1. All right, so I can see that my a squared, and remember I'm determining which one a is by the positive one. Okay, so a squared is 4, so that means a is equal to 2. So that means my vertices, because they are with the x, are -2, 0, and 2, 0. And then I can see here that b squared equals 9, so then b is equal to 3. So I can make some notches here. We'll go ahead and go 1, 2, 1, 2, and then b is in going 1, 2, 3 in the y, and down 1, 2, 3 in the y. And note, once we've determined a and b, we can go ahead and sketch our box, right? Our box always goes from -a to a and -b to b in either the x or y direction, respectively, just depending upon whether the x or the y is the positive term. And so we know that, and we know the vertices are with the x, right? Because of the fact that x is the positive term. So I can put these nice solid points right here and right here at the edge of these boxes. Let me fix that vertical line I made there. And then I know that I can get my asymptotes here. I can state, first of all, that my asymptotes are y equals -3/2 x and y equals 3/2 x, right? Just taking b over a and -b over a. These are my asymptotes. But I can easily sketch them just by connecting up the corners of my construction box. So I know that in the long run, my hyperbola needs to approach these asymptotes. So I know that we're going to have some sort of a shape like this that approaches these asymptotes as I go on. And same thing on this side. Now the last thing we need to do here is we do need to graph the foci. So remember that for our foci, we have that c squared is equal to a squared plus b squared. So c squared equals a squared plus b squared. All right, but of course a is 4 and b is 9. So c squared is 13, so that means c is equal to the square root of 13. And it's worth getting the approximation here. So square root of 13 is about 3.6. So what we know is that, you know, the foci, they have to be on the same axis. They have to be on the transverse axis, right, with the vertices. So that means that we have negative square root of 13, which we know is about negative 3.6, and positive square root of 13, comma 0. Those are our foci. Oops. And so if this is 1, 2, 3, 4, so about 3.6 is going to put me right about there. And then back, -3, -4, so -3.6 puts me right about there. So we always remember to graph the foci because that's a part of the graph of a hyperbola. So here's another example. So they give us this equation, 4y squared minus 2x squared equals 1. Now first we can see that our vertices are going to be in our y, right? Because that's the positive one. But what are we used to, right? They told us that we should be expecting something like this, y squared over a squared minus x squared over b squared equals 1. So we know what to do when we see that we're dividing our y squared or our x squared by something, but right now we're multiplying. All right, so what we need to do is force this equation to show us division. So we think about multiplying by 4 is the same as dividing by what? Well, we know that multiplying by 4 is the same as dividing by the reciprocal, which is 1 over 4. Right? And we can quickly see, okay, yeah, if I flip this and multiply, I get 4y squared back again. I do the same thing here. Multiplying by 2 is the same as dividing by a half. So that tells me that a squared is equal to 1/4, so that means a is equal to a half. And b squared is equal to 1/2, so that means b is equal to the square root of a half, or 1 over the square root of 2. All right, now we're going to want to be able to graph this, right? So first we will note that we're going to have vertices at -1/2, at 0, -1/2, and at 0, 1/2. Right, those are our vertices. And let's go ahead and get an approximation here. So this is 0.71 approximately. So we know about where to put the edges of our box. So we can start to make that box now. Since we're under 1 in both of these, what I think we probably ought to do here is just go out to 1 to -1 in both x and y. So that way I can really see what's happening here. So we'll just make our kind of a small scale here. So the vertices are on the y-axis. So here's +1/2, and here's -1/2. And then for b 0.71, might put me right about there and there. So we can go ahead and make our box. And we can sketch the asymptotes here through the corners of our box. All right. And then let's talk about our foci. Our foci, well, to find those, right, we'll again use our c squared is equal to a squared plus b squared. So c squared is equal to 1/4 plus 1/2, which of course this is 2/4, so this would be 3/4. So that means c is equal to the square root of 3/4, which simplifies to square root of 3/2. So we'll have one focus at 0, -square root of 3/2, and at 0, +square root of 3/2. And by the way, the square root of 3/2, that's approximately 0.87. Okay, so we're still within 1. So we're going to put a focus right about here and a focus right about there. So I know that what's going on here is this. This branch of my hyperbola approaching these asymptotes in the long run. And you can see I didn't do a very good job on that top branch there because of the angle my hand was making, but the point is I've got the asymptotes there, I got the foci there, I've got the branch and the vertex in the correct spot, so I've kind of shown all the important stuff even if my branch is a little bit ugly here. All right, now example 3 says to find the equation of the hyperbola with foci of 0, 5, and 0, -5, and vertices of 0, 4, and 0, -4, and then sketch the graph. Okay, so the fact that the foci are 0 and then plus or minus 5 means that C is equal to 5. And the vertices are 0 plus or minus 4 means that A is equal to 4. And so, since we know that C squared is equal to A squared plus B squared, and we know C is 5 and A is 4, we can solve for B. So 25 equals 16 plus B squared. So 9 is equal to B squared, so that means B is 3. So first of all, just knowing B squared allows me to write out the equation, right? The vertices are with the Y, right? So that means Y squared over 16 minus X squared over 9 is equal to 1. All right, now we have everything we really need to sketch the graph of this, right? So we know that we have foci at 0, 5, and 0, -5, vertices at 0, 4, and 0, -4. So you can start making tick marks here. Vertex here, focus here, focus there. And then because B is 3, we just know we go in the x3 and -3, and that will allow us to form our box. And once we have our box formed, that's when we can sketch our asymptote. So we know what this hyperbola has to do in the long run. All right, one last example. They give us vertices again, but this time they tell us what the asymptotes are. So here, right, we know that A is equal to 6, right? And so of course A squared would be 36. And because the vertices are of the form 0 and then plus or minus 6 in the y value, we know that y squared over a squared, which is 36, that's the positive term. So we're going to have a squared, or x squared over something, is equal to 1. Fix that. So we got to figure out what belongs down here, right? In other words, what is b? Well, what we need to remember here is that in a case like this, if you have asymptotes of plus or minus 3x, then y equals plus or minus a over bx. That's what your asymptotes look like, right? Because if I go up 6, I know there's a vertex there, and down 6. There's one there, right? And so I know that I'm going to form my box as having a height of -6, going from -6 to 6, right? So A is the change in y of your asymptote, and so B would be the change in x. All right. So the fact that A is 6, we know that. That means that the fact that we know it's y equals plus or minus 3x, if I put 6 in for A, I know the only way to make that equal to, sorry, there should be an x right there. The only way to make 3 equal to 6 is to divide it by 2. So that tells me that B must in fact be 2. So if B equals 2, then that of course means B squared is equal to 4. So that gives us our formula. And so I can go 2 notches in either direction here. That's going to allow me to sketch my box. But we'll also go ahead and take the time to find our foci. So c squared, we know, is a squared plus b squared, so that's 36 plus 4, which is 40. So that means c is equal to the square root of 40. And we can do a little better than that, right? The square root of 40 is square root of 4 times 10, which is 2 roots of 10. So to put it nice and simplified, we would say that our foci are 0, 2 roots of 10, and 0, negative 2 roots of 10. And it's worth noting that 2 roots of 10 is about 6.3. So our focus here is actually really close to the vertice, right? If I go up another notch and down another notch, right, it's almost like you almost can't even distinguish them at this on this scale. So they're really close. And so if I go ahead and put my asymptotes through, then I'll be able to get a sketch of this thing.